Okay, just looking to give you a little help with assignment number 3. This is the infinite limits and asymptotic behavior assignment. So I thought I could do a couple of the odd problems, and then you could work the even ones. So with problem number 1, we're interested in the limit as x gets really, really large, and the function is 3x plus 1 divided by 5x minus 3. Now, the official way that we're working this is we're looking at what the highest exponent for x is, all right, which in this case is x to the first power. So we're going to divide each of the terms by that x. All right, so if we do that, we have the limit as x approaches infinity still, and we'll have 3x over x plus 1 over x in the numerator, and then 5x over x minus 3 over x in the denominator. Now what that allows us to do is eliminate these x's in the first term of both the numerator and the denominator. And this means if we rewrite it, we have the limit as x approaches infinity, and we have 3 plus 1 over x in the numerator, and 5 minus 3 over x in the denominator. Now we're interested when x gets really, really large. So like a billion. So if we were to plug a billion in for x right here, we have 1 divided by a billion. 1 divided by a billion is basically 0. It's not exactly 0, but it's quite close. So what ends up happening is we have 3 plus 0 in the numerator, and in the denominator we have 5 minus, and again we're going to plug a billion in for x. 3 divided by a billion is very close to 0, so we can, in essence, consider it to be 0, round it off to 0. So we have 3 plus 0 over 5 minus 0, or a final answer of 3/5. Now that's all the official math behind everything. But one quicker way of looking at it is, where's the highest exponent located? Is it located in the numerator only, the denominator only, or both? Well, the highest exponent is 1. It's the unwritten 1 here and there. It's located in both. And if that's the situation, well, then we know to focus in on our leading coefficients, the 3 and the 5, and they will produce our answer. So in a problem like number 3, it seems like the highest exponent is in the numerator only, but it's actually a trick, because in the denominator we have x minus 1 times x plus 1, and if we were to FOIL this, like so, from algebra class, we would end up with the limit as x approaches infinity. We have 2x squared in the numerator, and x times x is x squared, x times 1 is x, but negative 1 times x is the opposite of x, and then we combine those, they wipe each other out, and then when we do last, negative 1 times positive 1 is negative 1. Where's the highest exponent? Numerator only, denominator only, or both? We can see that it's both. So we're going to focus on our leading coefficients. The 2 here, and the unwritten 1 right there. Those leading coefficients are going to lead us to our answer. We have a 2 in the numerator, we have a 1 in the denominator, so our answer is going to be 2 over 1, or 2. And again, I just did the shortcut. I didn't go through the dividing by x, because you don't need to show that on the exam. Right? They're going to ask you a question like this, and all you're interested in is locating that highest exponent. It's in the numerator and the denominator. Okay, what are the coefficients? 2 and 1. Boom, there's our answer. If you have a situation like number 5, where the highest exponent is in the numerator only, what's happening here is the numerator, when we plug in a billion, it's like a billion squared. But in the denominator, we just have a billion plus 1. And a billion squared divided by a billion leaves us with a billion. If we plug in a bigger number than that, say a trillion, we'll have a trillion squared divided by a trillion, which leaves us with a trillion. Well, we just grew from a billion to a trillion, and that's what's going to keep on happening. There is no leveling off. The highest exponent is in the numerator only, and if that's the situation, that means our limit will not exist.